Okay, there are a couple of tricks that we're going to use finding this integral. First, notice that it looks like something we might be able to use trig substitution for, but the denominator isn't perfect yet. But we can make it so by completing the square in the denominator. So let's notice that we can write x squared plus 2x plus 2 as x squared plus 2x plus 1 plus 1, just using the very simple fact that 2 is equal to 1 plus 1. Now if we group these terms, it's clear that this factors as the quantity of x squared plus 1 squared, x plus 1 squared plus 1. So great. That gives us a way to rewrite this integral as x over the square root of x plus 1 squared plus 1. Great. So now we can take a u substitution. So an obvious choice for a first u substitution would be u equals x plus 1 and see how that works. So I forgot my dx. So if u equals x plus 1, then du equals dx. And let's see where that gets us. So we've taken care of this bit. We've taken care of this is u, but the x is by itself. But that's okay because this is easily solvable. And notice that means that u minus 1 equals x. Great, so we can replace this term with u minus 1. Okay, so let's see where that leaves us. That leaves us with u minus 1 over the square root of u squared plus 1 du. Great. Now we can separate this into two different integrals. So we'll separate this into u over the square root of u squared plus 1 du minus 1 over the square root of u squared plus 1. And we're going to have to attack these each separately. So this one will be done with just a substitution, and this a simple substitution, and this one can be done with a trigonometric substitution. So let's see how it works. Maybe here we could let v equal u squared plus 1, which makes dv equal 2u du, and let's see what that does. So this becomes v, and then all the stuff that's left over is 1/2 dv. So that changes this integral into the integral of 1/2 we can bring out front, and then we have a square root of v in the denominator, which is the same thing as a v to the minus 1/2 dv. So now we've taken care of that. Now let's see what we can do here. So here, this one is probably best done with a trig substitution. So let's see. If it's u squared plus 1, then we should let u equal tangent theta, which makes du equal to secant squared theta d theta. And then u squared plus 1 will also be secant squared theta. So let's see what that gives us. That gives us minus the integral of secant squared theta d theta over the square root of secant squared theta, which is secant theta. Now this will cancel with one of these, and then we're left with the integral of secant theta. Okay, so now we're ready to start again. So notice after all our substitutions, which I've condensed down here, we have our original integral is equal to the difference of those two given integrals, again with these substitutions. So let's see where that takes us to the end. So this is going to be 1/2. So we'll increase the exponent by 1. So that'll give us v to the half, and multiply by the reciprocal of the new exponent. So that's 2 over 1. Good. And then minus the antiderivative of secant theta. So this is a tricky one, but you can look it up, and it's the natural log of secant theta plus tangent theta. Okay, good. So now, as we can see, these 2's will cancel, and then when we substitute back in, we have v equals u squared plus 1, u equals x plus 1, but that'll just give us this term that's in the denominator here, So we have, and then taking the fact that the half power is the same thing as the square root, we have the square root of x squared plus 2x plus 1, and then minus the natural log of, so if the tangent of u, so we can write this as u for the tangent of u, and then secant theta, we can complete our triangle to figure out what that is. We can either do that, or we can use the fact that secant theta and tangent theta are related via a trig identity to give us the square root of u squared plus 1 there for secant theta. And then finally, we can finish it off. So by substituting back in for u. So here we have, and sorry, this should have been 2. The square root of x squared plus 2x plus 2 minus the natural log of, so u is equal to x plus 1 plus, and then u squared plus 1 is again the square root of x squared plus 2x plus 2. And then we have our constant of integration. So that one was a long one, but it goes through a lot of nice techniques for solving integrals.